Welcome student. In last lecture we discussed about the scope of CAD CAM. Now in today's lecture we discuss about the software modules. Each CAD software has its own strength and it usually targeted towards as a specific market and group. Accordingly, the software modules are designed. All CAD software has nearly a same genetic structure and common modules. For example, Creo, which is extended version of Pro Engineer, is a family or suite of computer-aided design software. CATIA is also one of the example. CATIA is a computer-aided three-dimensional interactive application. Both are used for modeling purposes. Here we see an example of a Creo. Some windows you see on a screen on that slide. You can see the Creo having types and some subtypes. Types are layout, sketch, part, assembly, manufacturing, drawing. You can generate a report. Then in a subtype, you can go for solid or sheet metal. Okay, all these things are very robust in Creo. Also, you can find in a slide that with the help of Creo, we can do a modeling and you can do an analysis. You can annotate the things. You can render. There are some tools availability is there. So the overall the Creo software is robust. As I said earlier, all CAD softwares are nearly having a common modules. What are these modules? Let we see. CAD software modules. One is the operating system. Operating system contains number of functions for manipulation or for the manipulation of information specific to a given application rather than an environment as a whole. You can run and you can quit any application at any time, or it can integrate the running application for its specific information. So the function are to run command system commands, and the examples are while to managing a directories, to do a manipulation. These are the example of operating system. Next one is a geometric modeling. You can do the function of geometric model is to edit, to manipulate, to draft, to document the object. Example are solid creation or the model creation, plotting, to clean up the things. Okay, these are the example of a geometric model. Application model, you can use model for design and manufacturing purpose. Analysis purpose, you can use this model for animation by using numerical control. You can do a simulation. These are the functions of application module. So example are whatever the analysis we are doing on a object, means finite element analysis or computational fluid dynamics or tolerance analysis. All these are the example of a application module. Next one is the programming module. The function of programming module is to customize system to fit certain design and manufacturing tasks. For example, AutoLips. In AutoCAD, Lips is a language. Lips is nothing but a list processing. This is the acronyms. The acronym of Lips is list processing. Is a programming language that was designed for easy manipulation of data strings. This is a common language which is used for artificial intelligence. Similarly, macros, if you have a task in Microsoft Excel that you do repeatedly, you can record a macro to automate those tasks. A macro is an action or a set of actions that you can run as many times as you want. So this is about the programming module. Communication module. In this communication module, the functions are the integration CAD CAM system, other computer system and manufacturing facility. Suppose you make a model and you want to transfer this model from one software to another software, then the communication module is very useful. So you can give an extension to that file, IGES or STEP. IGES is the integrated graphic exchange specification, or STEP is the also one of the neutral CAD file format, which can be used in any software. So we can suppose you want to open that part in other software. If your file having such kind of extension, then that file will open in any software. This is the example of communication module. Next one is a collaborative module. Here various teams in different location can work on same platform, or suppose at a different location you can do assembly at particular workstation. Now the cloud working is come under the collaborative module. This is the example of a collaborative module. This is all about the module. Now we will going to discuss about the 3D modeling. Already we defined 3D modeling is the process of developing a mathematical representation of any surface of an object in 3 dimensionals via specialized software. The 3D modeling approach are primitive approach, picture based approach, and sketching approach. Let me see these one by one. Primitive approach. In this diagram, you can see primitives are the 3 dimensional building blocks. The basic geometric forms by using this block as it is, or modify with transform and boolean operation. Means we can simply adding or subtracting the standard shapes to get a desired output, desired shape. Basic primitive shapes are like sphere, cuboids, cone, torus, wedges. Okay, these are the different standard primitives available. Now with the help of these primitives, you can see there the approach. By considering two shapes, we are generating one shape. Again, what will be the integrated shape? That is also combined with another shape to get a desired output. This is the primitive approach we can see. Next one is a feature based approach. It is similar to primitive approach. It replaces primitive with a feature and embed boolean operation in the feature definition. Each feature can be independent or linked to other feature. The geometry of each feature is controlled by modifiable constraint and dimension. This is all about the feature based approach. Next one is the sketching approach. User can express their intent by sketching 2 dimensional shape, then various feature will be applied to generate 3 dimensional model. From this diagram, it get clear. We make a sketch and then we are using some commands. Extrusion. Suppose here you are using. Suppose you are using here a extrude command. Okay, then we will get a model, 3D model, in a as a output. Now let us see about the type of geometric model. Basically, there are three types of geometric model. That is 2.5 dimensional model, 3 dimensional model, and composite model. In that 2.5 dimensional model, it is extrusion axis symmetry. Now extrusion, constant cross section and thickness in a direction perpendicular to the plane of cross section. Axis symmetric, constant cross section about the axis of revolution. From this diagram, it is get clear that in extrusion, the thickness of model is uniform, and in axis symmetric, about the axis, the section is get revolve. Means from about the axis, the shape of a profile is symmetric. Then next one is a 3D model. It does not have any geometric uniformity like in 2.5 model. If you see here in a diagram, the two different shape may get blend here in this 3 dimensional model. Composite model, it is a combination of extrusion and axis symmetric. If you see in a diagram, you can find Some of the part is done with the help of extrusion and some of the part is done by axis symmetric. Now let me see a next part, that is three-dimensional geometric modeling techniques. There are basic three types of three-dimensional geometrical modeling techniques. First one is a wireframe model, second one is a surface model, and third one is a solid model. Let us first understand the wireframe model. A wireframe representation is a three-dimensional line drawing of an object showing only the edges without any side surface in between. A frame constructed from thin wires representing the edge and projected lines and curves. It contains information about the location of all points and edges in space coordinates. Each vertex is defined by x, y, and z coordinate. Edges are defined by pair of vertices. Faces are defined by three or more edges. The diagram shows the wireframe model. Now, what are the advantages of wireframe model? Advantage of wireframe model, we can say it can be quickly and efficiently convey information than multi-view drawing. The only line seen are the intersection of surface, can be used for infinite element analysis, can be used as input for CNC machines to generate simple parts. It contains most of the information needed to create surface, solid and higher order models. Now, if you see about the limitation of wireframe model, ambiguities present in the wireframe model is the main drawback. Always there is a confusion where the line complete or where it intersect with other edge. Volume of surface of object not defined. For complex atom, the result can be jumble of lines that is impossible to determine. Limited ability for checking interference between mating parts. No ability to determine computationally information such as the line of intersect between two faces of intersecting model cannot be used to calculate dynamic properties. Now overall, when we see a strength of wireframe model, we can say computationally the most straightforward is become a strength, most economic in terms of time and memory requirement. Geometry is defined as a series of lines and curves representing the edges, useful for visualization of simple shapes and animation of simple mechanism. These are come under the strength of wireframe model. But when we see weaknesses, then ambiguity in representation, deficiencies in pictorial representation, limitation in the ability to calculate mechanical properties or geometric intersections, limited scheme as a basis for manufacturing or analysis. These are all the weaknesses of the wireframe model. Now, next one is a surface model. Surface model. A surface model represents the skin of an object. These skins have no thickness or material. Surface model define the surface feature as well as edges of the object. Mathematical functions describe the path of a curve. In a diagram, you can see here a general curved surface and bilinear surface. Advantage of surface model: eliminate ambiguity like wireframe model, can use for CNC machining mold and die design for FEA. Typical application of 3D CAD surface modeling include body design in automotive and aeronautic engineering and the representation of complex geometries. Surface properties such as roughness, color and reflectivity can be assigned and demonstrated. Volumetric properties of an object can be easily obtained. Now, take a look on a limitation of surface model. Surface model provide no information about the inside of an object. Complicated computation depending on the number of surfaces. So, overall, if you see about the strength and weaknesses of surface model, we can say that unambiguous representation of a 3D model, significant advantage over wireframe model in the link to manufacture and to engineering analysis are the strength of surface model. Let us see our weaknesses. Weaknesses are more computationally demanding than wireframe, more skill in construction and use, no merit without hidden surface removal, no connectivity between surfaces, objects are represented as simple collection of surfaces. Some geometries are difficult to represent using surface modeling scheme. Now let us see about the solid model. Solid enable a complete and compact geometrical representation of object in a virtual environment. Solid model are capable of defining closing conditions, inside outside information and geometrical consistency specification. It able to define material properties, supports the realization of several physical simulation. It improves the quality of design, improves visualization. Simulation under real life conditions and less expensive than building a physical model. It can be used for presentations and marketing. From this diagram, it is get clear the whatever the limitation you found in surface modeling and in wireframe, all these things are get clear in a solid model. Now if you see strength and weaknesses, now we can say that models are constructed as a combination of simple solid primitives set theoretic model by using a boolean operations. CSG models tends to be more robust performance advantage for the test. All these things are come under the strength category of solid model. Now if you see a weakness, models are stored in an unevaluated form, edges and faces from the combination of the primitives have to be computed when required. Attendant performance penalty. Smooth combination between two primitives may be difficult or time consuming. Like suppose we say we have to do a fillet blend, then we are not getting a smooth curves. So we get at the end, but it takes more time. More complex form are impossible to model using CSG. Generally, regarding that automobile body panel design. Okay, so these are all the weaknesses of a solid model. Now, this is all about the 3D approach and a geometrical model techniques. Okay, in next lecture we will see about the modeling strategies. Thank you.